Greetings, Earthlings! In this video, we're going to go over complex numbers and their operations that will appear on the Algebra 2 SOL. Complex numbers are represented by the letter I, the value of I being the square root of -1. The most common use of imaginary numbers in Algebra 2 that are represented by I involve having the negative square root of some number. Answers are expressed in a plus bi form. Let's do a quick example as a refresher. Let's say you're asked to simplify the square root of -64. Well, we know that the square root of 64 is 8, but in this case we have a negative under the radical. Oh no! What do? Cry? Scream? Panic? The answer to that question is none of the above. Take the negative out of the radical by rearranging the expression to the square root of 64 times the square root of -1. After that, we know by definition that the square root of -1 is I, and the square root of 64 is 8. So the answer is 8i. Let's refresh your memory by working on a quick example. Let's say we have to simplify the square root of -24 times a squared times b to the 5th. Excuse my poor penmanship. The first thing we should focus on is trying to get that negative out of the radical, because we don't like negatives under the radicals. After moving an I in front of the radical, simplify what's left under the radical. And once you do that, this should be your answer. And I'd say that's pretty radical. Well, I guess my sense of humor is imaginary too. Now let's move on to review the fairly simple operation of adding complex numbers. Let's do this problem as an example. The first thing we're going to want to do is take the negatives under the radicals out of the radicals, because we don't like negatives under the radicals. We can then add or subtract like terms after taking out an I. And once you do that, this should be your answer. Notice how it's an a plus bi form. Let's move on to another operation with complex numbers, subtraction. Let's take on this problem. Like we did with addition, the first thing we're going to want to do is take out the negatives under our radicals, because once again, we do not like negatives under the radicals. After that, we'll have it in terms of I, and then we can add or subtract like terms. And after you do that, this should be your answer. A few things to remember for this portion of the Algebra 2 SOL. You should know the values of I squared, I cubed, and I quadrupled. They'll come in handy if you run into a problem where I is raised to some high power. In addition, you should already be familiar with the quadratic formula and the method of FOILing to expand. With that in mind, let's look at this problem I've worked out. I FOILed to expand, added like terms, and simplified. Not too complex after all, I'd say. Conjugates of complex expressions are very simple. We'll use this problem as an example. Which of the following is the conjugate of 5 minus 3i? All you have to do to find the conjugate is take the middle sign of the expression and make it the opposite sign. If it's plus, the conjugate will be minus, and if it's minus, the conjugate will be plus. And the correct answer is D. Now let's move on to dividing complex numbers with the example problem 2 minus 4i divided by 1 plus 3i. Remember that we can't have any imaginary numbers in the denominator, so what do? Scream, cry, panic, call 911? Nope. We simply multiply the numerator and the denominator by the conjugate of the denominator to get that I out of there. After that, we distribute by FOILing. First, outer, inner, last. And after that, it's a matter of simply simplifying, and your answer should be -1 minus I. And that makes you happy inside. Now on to the next topic, polynomials with complex number solutions. For this example, we're asked to find all values of x to make x squared plus 3x plus 12 equals 0. You'll quickly find out that you cannot solve for the zeros of this polynomial by factoring. Feel like beating your head against a wall? Don't worry, we can still use the quadratic formula to find out the zeros of this polynomial. While working out this problem, you'll find out that the junk under the radical is negative. That junk under the radical is called the discriminant, in case you want to impress your math teacher. All you have to do is take out the negative from under the radical by taking out an I and placing it in front of the radical. Unfortunately, this was not done in this problem, so the answers that are on the board are mega wrong. The two correct answers should be x equals negative 3 plus I times the square root of 39 over 2 and x equals negative 3 minus I times the square root of 39 over 2. I apologize for that, but hopefully that was a test to make sure that you're on your toes. The last complex number topic covered in this video is simplifying I raised to some power. We'll use a new SOL technology formatted question to practice this concept. I know seeing these kinds of problems result in your facial expression looking like this, but this problem will prove not to be too bad. For this problem, you have to select all values that simplify to negative I. So, you have to simplify each answer given. This sounds tedious, but simplifying these expressions will prove to be easy. You should know the values of I raised to the first, second, third, and fourth power already. If the power or exponent is greater than 4, divide the exponent by 4. Whatever the remainder is out of that number, that's your simplified form. Simple as that. After simplifying all the answer choices, we find that the first, fourth, and fifth answer choice are correct, so we select those answer choices. That's it. We've covered all the different complex number topics that could appear on the SOL. Using review tools such as these will make this exam powerfully easy. Good luck and have a clawsome day.